Let's look at some even and odd functions and discuss symmetry a little bit. So with even and odd functions, we can see it graphically and algebraically. So for an even function, what should hold true is that if you plug in negative x and simplify, you should just get the original function out. So plugging in negative values doesn't really change the output of the function. Visually, it's going to be symmetric about the y-axis. So let's take a look at our even function here. So this is our function x squared. And this is symmetric about the y-axis. So why that is if I imagine that I have my y-axis here, the idea is that if I had heavy paint and painted along my function there, and then folded my paper in half, and I fold it along that y-axis, that function's going to land on top of itself. I'm just going to get a smear of paint on top of itself. It's not showing up anywhere new, so it would just land on top of itself. Or you can imagine if you just painted half of it. So if I just painted this side and then folded in half, then the paint would smear right on top of that other half. So that's where it's symmetric about the y-axis, is that the y-axis is acting as this axis of symmetry, where it's like a mirror for our function. Now, algebraically, what's being described is if our function is x squared, if I look at plugging in negative x, what that would look like is parentheses negative x, and those parentheses are super important, and then my exponent of 2. Well, what this would do, and this is true for any even power, which is where we're starting to see how even functions connect, is with that even exponent there. Well, if I have an even exponent with a negative number, it's positive. Because if you have an even grouping, like this would be negative x times negative x, that would just be positive x squared. And if that was x to the 4th, then I would just have positive x to the 4th. When you have these groupings of 2's, these even groupings, the negative is going to turn positive. So what this means is when I simplify, is the negative is positive because of that even exponent, and then I'll have x with that exponent of 2. So that's where I just get x squared out, which x squared is the exact same thing as f of x. So with that, I end up with this relationship that if I plug in and simplify f of negative x, it's just the same thing as my original function. And that's our proof that it's an even function. Now, odd functions, if you plug in negative x into the function, what should happen is it should be the same as negative 1 times your original function. So we'll look at that. Graphically, what it is it's symmetric about the origin. So what that means is where the even function only dealt with the y-axis, to be symmetric about the origin, we're going to use the y-axis and the x-axis. So let's say we reflected this function. That would mean is, let's start with the y-axis. It doesn't matter which order you go in. You could do y-axis and then x-axis. Doesn't matter. So let's say I did that. I have my piece of paper and I used that paint. I painted the function, I loaded up a ton of paint on it, and then I folded my paper over that y-axis. What would happen is I would end up with something that looks roughly like this. Alright? Meaning the paint over here would graph those pieces on that other side of the y-axis. Same thing over here. So reflecting those pieces, I would end up with that blue graph right there. So that's reflecting it over the y-axis. And this proves that it's not an even function because it didn't land on top of itself. If we just got the same graph out, then it would be even. But we got something totally different. But now what happens if I reflect my new blue graph over the x-axis? Meaning, I'm going to load up this blue graph with a bunch of paint, and then I'm going to fold it over that x-axis. What would happen are these points would start going, and they're going to start mapping to that original graph that we started with. So what's up above the x-axis moves to below the x-axis, and what was below the x-axis moves to above the x-axis. So what would happen is we would end up graphing on top of that very original function that we started with there. So we could get rid of that blue graph, and we'd end up back where we started. So this idea of symmetric about the origin is this idea of two reflections, across y and across x. Or you could go across x and then across y, and you get the same thing. So with that, let's look at algebraically. So this graph right here is f of x equals x cubed. Again, you can see there is this relationship between the exponents and the type of function it is. So f of x equals x cubed. So let's see what happens when we plug in negative x. So we're going to have in parentheses negative x cubed. Now, whenever we have an odd number as our exponent, it's that, like with 3, we'd have negative x times negative x times negative x. So what you'd end up with are these pairings that would make for positive numbers, so that would make a positive x squared. And if I had just even a larger odd number, so we'd have these pairings that would make these positive numbers, but then you'd always have one more. You'd always have one more negative 1 multiplying on. So what that means is simplifying these, we'll always end up with a negative out front. So this is the same thing as negative outside of the parentheses and x cubed. So that negative x cubed, well, that's the same thing as negative 1 times our original function. That's the same thing as negative 1 times just f of x, where f of x is x cubed. So with this, we're showing that f of negative x is the same thing as negative f of x. And we'll practice this more down below here. So let's see that with our functions. What we'll do is first look at it algebraically, and then we'll take a look at the graph to see how that works out. So proving algebraically, what I do is start with plugging in h of negative x, or f of negative x. We're going to do this for all of them. So first things first, look at plugging in negative 1 times your variable and simplify. So for our first example here, I'm going to look at h of negative x. And that's going to look like negative x cubed minus negative x. And then I'm going to simplify. So this first one here will be negative x cubed. And then subtracting negative x is the same thing as plus x. Now the first thing I do is check to see if it's an even function, because that's kind of the easiest one to do, which would be looking at the function we ended up with, and is it the same as the original function, which it is not. So it's not even. But then what we could do is compare our h of negative x and compare it to negative h of x. So what that would look like is negative 1 times our entire function, which would be negative x cubed plus x. And that's coming from distributing that negative 1 in. And now what we could see is that those are exactly the same. So those two are equal, which shows me that this is an odd function. So let's look at the graph of it. Y equals x cubed minus x. So what we could do is imagine this kind of double reflection, so reflecting over the y-axis, and then reflecting over the x-axis, and that's going to line up. I know it's kind of hard to show with just a mouse and a computer screen, but again, you can imagine, kind of like I described, that idea of loading a bunch of paint on top of it and folding the paper, and then we'd load up paint again and fold the paper over the other axis, and it should land right on top of itself. Alright, let's look at this function here. So we're going to plug in negative variable, so negative t. So this is 1/2 negative t to the 4th minus 1. And since we have an even power, that's just going to turn positive. So that's just positive t to the 4th minus 1. And then what you'll notice is that our function is the exact same as the function we started with. So with that, we can see this is even. So let's look at the graph for it. So we're going to have 1/2 x to the 4th minus 1. Yeah, with the functions where we use different letters, when you're using a graphing calculator, just stick to y and x. Using other letters sometimes mixes things up. So with this one, all we needed is symmetry about that y-axis. So yeah, if I painted over my function and then folded over the y-axis, it would just land on top of itself. Alright. X cubed plus 1, we're going to look at g of negative x. So we'll have negative x cubed plus 1, which would be a negative x cubed without parentheses plus 1. Now, that's not the same as our original function, so this isn't even. Another big hint is the fact that we have an odd exponent, so really what I want to check for is something odd. Like up above here, we had odd exponents. Here, even exponents, so we ended up with an even function. Here, odd exponent, but something special is going to happen with this plus 1. So let's see what happens when we look at negative g of x. So that's where you would take negative 1 times this whole x cubed plus 1, and distributing that negative in, it would be negative x cubed minus 1. So to have these two be equal, we're missing our sign on that plus 1 minus 1. Those aren't matching up. So those are not the same. So this just shows that it's not even, it's not odd, so we would just say neither. So let's take a look at the graph of this. X cubed plus 1. So if I start reflecting, so I could reflect over the y-axis and get this kind of squiggle. I would still be going through this point 0, 1 there. But then when I reflect over the x-axis, what would happen is that 0, 1 would then be down here at 0, negative 1. So if I do my two reflections, even just following this 0, 1, it would stay put for the y-axis reflection, because it would just land on top of itself. But then it would be moved across the x-axis, and I'm landing somewhere totally different. So if you kind of play around with drawing this on your paper and thinking about folding it and moving it around, when you do the two reflections, you'd end up somewhere totally different. So with that, it's not even, it's not odd, so we just say it's neither. Let's look at one more example here, and we could already get a hint that, so we have odd and even. So let's see what happens when we mix the two together. You might already have an idea of what might happen, but let's prove it. So m of negative t, so we would have, this mixed variables, m of x, sorry about that, m of negative x, so we'd have negative x cubed plus negative x squared. So in simplifying, that negative x cubed would lose its parentheses, and then that negative x squared would be a positive x squared. So as we can see, the negative x cubed, it's not exactly the same as the original function, so it's not going to be even. And if it was odd, then we would have negative x cubed minus x squared. So we would change the sign of each piece, but we do not have a minus x squared there. So this is neither. Let's take a look at the graph of this one. X cubed plus x squared. So, kind of similar idea here. Let me kind of focus on this point. It's not the prettiest of points, but let's focus on it. It's negative 2/3 and a 0.1481. So if I reflected over the y-axis, it would move over here to the right-hand side. Then I would reflect it over the x-axis, which would throw it down here to quadrant 4. So doing the two reflections, we'd end up somewhere totally different. If this was an odd function, it should do those two reflections and end up at its starting position. But that's not happening here, so that would just prove that it's neither. Alright, so that's how we can look at odd and even functions algebraically, as well as from the graph.